Hi, so welcome back. So last week, what we saw is some basic plotting of graphs or plots using ggplot2. We also discussed about how ggplot2 works. It is like there are multiple layers and each layer can be controlled independent of each other. And for a plot, the minimum variables or the minimum layers it needs is the data layer, where you have to specify what the data is, then aesthetics, which is in terms of what is your going to be X coordinate or Y coordinate. So which column you want to pick it up as your input data. And then finally is the geometry layer, which is where we specify whether we are trying to plot a scatter plot, bar graph, or histogram, or density plot. So depending upon our requirements, that's where we are trying to specify in the geometry layer. So today we'll see a little bit more aspects associated with it. So we'll see something called facets. I don't know how to say it. I call it facet. Maybe there's another way of saying it, but it's a facet layer. So essentially what a facet layer allows you to split your graph based on certain variables. So we'll see an example and hopefully that will make it more clear. So let's have a quick look at empty cars data set. Okay. And let's have a look at head. And you can see that all the other variables we have previously have looked at it. One of them is AM, which is generally automatic and manual. So 0 is automatic and 1 is manual. So what we're trying to do here is rather than basically having 0 and 1 variable, we are trying to replace them with proper names, like 1 stands for manual and 0 for automatic. So those are line number 72 and 73. The code actually is trying to achieve that. So which essentially says in empty cars AM column, which basically means wherever empty cars $AM equals to 0, which is I just substituted with automatic. And when it is 1, just substituted with manual. And now if we look at the head of empty car, the second thing, the next what you're doing in line number 75 is converting that particular column into a category or a factor, because that's what we expect. So there are 2 levels only to it, automatic or manual. So if we look at a head empty cars, what we will see is now instead of 0 and 1, in AM column, we have mostly like manual and automatic. Okay. So let's first do the basic plot here. So using and store into the variable P, and that's, let me pull it up so that it's visible. Okay. So we have seen this particular plot before, where we have miles per gallon as our y-axis, x-axis is actually the weight of the cars, and then we have 2 other variables. So one is coded in the color, another is on the shape of each data point. Now, sometimes, let's say there is a requirement, let's say we want to see a behavior of how the automatic car and how the manual cars are behaving, or what's the distribution of data points in automatic and manual cars separately. We don't want to see them in the same graph, but we want to have 2 graphs. And that's where the facet thing comes into play. And the facet, generally we describe facet is your horizontal. So if you want to split something by horizontal, like you want, so this graph, if you want to split into horizontally, 1 graph on the top, 1 at the bottom, that's called horizontal split. And if you want to split 2 graphs side by side, that's you can think of as a parallel split. So whichever variable you want to, you specify how do you want to split your graph. So you specify what you're going to use for horizontal split. If you don't want to use anything for splitting horizontally, you put a dot. And you specify the vertical split. How do you want to split this graph vertically, like 2 graphs you want to make, and what variable do you want to use for vertical split? And if you don't want to use the split if you don't want to use any variable, you put dot. So now let's say the P, so the variable P, this is what it holds. It holds a graph with miles per gallon and weight. Now, what we're trying to do here is we are applying facet. Now, if you look at the, so in place of split horizontal, I'm just putting a dot. Basically, I don't want to split it horizontally. And then tilde, and then I'm in place of the vertical split, I am saying AM. So I'm saying use the categories that are available in AM column to split this graph. And so if you execute this, this is what we're going to get. You get the automatic on one side and manual on the other side. So now basically having everything together, we split it around into two different graphs. All right. So let's have a look at another one. This is the same plot, but this time basically not too many variables. So you can say it's a pretty standard. So we are not QSEC, and then what you can say, the cylinder information is not there. It's a simple scatter plot. And in this one now, I'm going to use again facet grid to split it. And this time I'm putting it on the horizontal side. So I want to split horizontally. And now this time horizontally, I'm splitting again by AM. By vertically, I am putting a dot. So this is not going to get split by vertically. So if you do now, then you see two graphs side by side this way. You can say automatic and manual. So depending upon the kind of data you're playing with, and you want to split whichever way you can use it. So the next, again, here we are splitting. We know that in our data set, empty cars, cylinders are of three different categories, 4, 6, and 8. So here what we are, rather than, again, I'm splitting it vertically by cylinder. So this time the P, because this is our standard graph. The main graph is that one, and then we are splitting each one of them. That's the advantage of it, because once if you describe this particular variable, your original graph, you can keep changing facet grid, and the split will keep happening depending upon what variable we are going to specify in the facet grid. So now here what has happened now, the split in a way vertically they have got split by 4, 6, and 8 cylinder, and each car's weight, miles per gallon versus a weight distribution is in each of these particular plots. Let's say we want to take into account both automatic and cylinder. So that's the next one is, and code in line number 95, you can see P, which is our original plot. And then we are using facet grid to split it. And this time we are going to split horizontally by AM, which is automatic or manual. And vertically, we're going to get cylinder by cylinder. So now we're going to have graphs. All the automatic cars with 4-cylinder, automatic car for 6-cylinder, automatic car with 8-cylinder, manual car with 4, manual car 6, manual car with 8. So in total, we are going to have 6 different plots, as you can see here. This is quite useful. Like if you want to split your data into multiple, you want to see how each of the data, your original data behaves in with respect to some other additional variables. You can use the facet grid to play with it. Okay. So this is pretty much with respect to facet grid. So that this is how you can split. So the main thing to understand in this one is just simply like you need to have a tilde, whichever way. The before tilde you specify how you want to split your graph horizontally, or after tilde you specify whether you want to split vertically and what variable do you want to use as vertically. And that's pretty much what you can achieve with the facet grid. So let's see, the next one is what either stat smooth or geom smooth. So let's have a look at that one. So this is our original plot. We have data S. So we again have miles per gallon and weight, and there is some distribution of these particular data points. And we want to fit some sort of a model through it. And it looks like this is not really any other polynomial kind of, it's pretty much straightforward. It looks like a linear model. So we're going to fit a linear model through this particular one, and we're going to use geom smooth. And in this case, all right, okay. Let me fit this one, and then I'll show you the other ones as well. So you can fit it using stat smooth, or you can also use geom smooth. Both of them actually going to give you the same results. So state smooth, you're specifying method is LM, which is a linear model. So you want to fit a linear model through this particular data. So it's going to work on the minimum of square of the residuals in order to fit this particular line. And the gray area which you see around it is actually standard error. And the next variable you're specifying is just essentially letting it know that the color has to be red. In this case, we are simply putting a, so for example, sometimes you don't want to fit a linear model, but want to have a variable. The line is fitting through your data point as the data points are along one of the axes. So what you can use is simply use geom smooth. So till here is pretty much the same. We have scatter plot, and here what we are using is to fit a geom smooth. And in that particular case, the line will be actually fitting as through the data. And again, the gray area is the standard deviation, standard error, sorry. And same geom smooth. If you don't specify any of the methods, it's going to be this way, a continuous fitting. If you specify a method, you can specify a linear model. Here we use stat smooth to specify linear model. Here we are using geom smooth to specify linear model. Both of them work equally well. So if you run that particular one, thus this way. Now let's say we have fit this particular data, but we want to see the fit based on, let's say, the in a way. So this, before going into that one, so let's say at some points you don't want to have, let's say, standard error plotted out, then you just say SC equals to false. So by default in geom smooth, the standard error is hold to true. So that's why you see this gray line or gray area around your line. So which is generally is a good thing, but sometimes may be required that you possibly don't want to. Then you can set it up SC equals to false, and then the graph would be something like this without any standard error to it. Now, this one from here, the next code is, if you look at, we are specifying data layer, we are specifying aesthetic layers, and then we don't have any geometry here. But what we are doing is the geom smooth method equals to lm, and no standard error. So what essentially is going to happen is not going, because there is no geometry there, is not going to do the geometry, but is going to just plot the line, because we haven't specified that we want a scatter plot. So that's why I just put the straight line through it. Okay. That was this one. So let's get back and have the scatter plot right now. All right, wait a minute. Yeah, okay. Now, the fitting you want to put is, so this is one way of actually putting through. Essentially, when we started with the data point, we know that there are data points with the 4-cylinder, 6-cylinder, and 8-cylinder cars inside our data point. So what we have done in this particular line is we specify ggplot, empty cars, aesthetics is x equals to weight, y equals to miles per gallon. And we're specifying here color is basically based on the cylinder. That's why the colors are 4, 6, and 8 are having individual colors. Then we did the geom point, and then we fit a line called geom smooth, which is method equals to lm. Now, what essentially happens, the method, the geom smooth is going to fit over this particular set of, we can say that 2 layers. And the 2 layers are, the first layer is our data layer, and the second layer is the aesthetics layer. The aesthetics layer has weight, miles per gallon. And then we have also factorized our data into 3 different groups, which is right now based on the color, 4, 6, and 8. And that's why when you fit the line using geom smooth, it fits on that particular those 2 variables, which is your data and aesthetics, and start having 3 independent lines fitting through all of them. Now, if possibly, let's say if you don't want to fit a line through each of the different data sets, want to have one single line fitting through, but want to have cylinders basically have in 3 different colors, then what we have to do is to move this particular from here and move into geom point. So we have to tell in the geom point layer that color based on the, you can see the cylinders. So, and then that's where it will, when it will color, those colors are not taken out by the geom smooth, because geom smooth works on this particular, the first 2 layers. And that's where we have categorized 4, 6, and 8. So it fits the different line. Now, these all 3 are in basically in the same graph. We can split into 3 individual ones by, let's say, adding facet grid. So we say facet grid, and then specify no horizontal split, split, but we want to split vertically by number of cylinders. And if you execute now this particular code, so my computer is a little slow today, but yeah, you can see now these three different data, basically three different cylinder cars of three different cylinder types are presented, and the line fitting through them is presented separately in each of the different graphs. Now, the idea here, what I'm trying to convey is that the initial concept which I introduced, that ggplot works in pretty much layers. So you can keep on adding layers. And when it is, when you try to visualize the graph, all those layers are flattened out into 2-dimension, and that's what is presented to you. And that basically having multiple layers allows us to keep on adding more and more, adding more variables, or make it this graph more and more complex. And that's quite nice about ggplot2. All right, so let's see the next one. So in the next one is, let's have a look at the code. So we are doing ggplot2. Data is empty car, aesthetics, x equals to weight, y equals to miles per gallon. We are going to do a scatter plot. So it's a geom point. We are going to do a stat smooth method equals to lm. We are going to fit a line lm, and the color is going to be red. So the line is red in color. And maybe ignore this one for time being. Okay, and then what we're doing is saying is scale. So these are the two variables which help you to configure your x and y axis. I will show you a more detailed example next, but here what we are saying is scale x, scale underscore y underscore continuous, and we are saying, okay, now change the label from mpg to, this is what we want, miles per gallon. Limits generally set up what your axis should start and what your axis should end in. So your y-axis should start with 0 and end up in 35. Your x-axis scale should be labeled as weight, and the limits starts at 0 and finish at 20. So let's execute this one. Now, if you look at this particular graph, that's what happens. So now you can see 0 to 35. And here is from 0 to 20. And you can see the little bit extra on either side. So this is called a padding. So by default, there is a 5% of padding. So it provides that extra space on either side. So that's okay. But otherwise, if you look at our scale, the scale is going from 0 to 30 and from 0 to 20. And our labels on X and Y axis has now been changed to what we desire. So I think one of the questions in maybe this session or morning session, somebody asked previously when we were doing ggplot2 is like, if you would like to have a more customized ticks or marks on or grids on X and Y axis, how to achieve that one. So a scale underscore Y underscore continuous and scale underscore X underscore continuous generally help you with that. So again, we're starting with your P, and you can see that now we don't have to write the whole code. We just simply add that we want to change this particular layer, which is a scale underscore Y underscore continuous, miles per gallon. Then we're changing our limits to, let's say, this was, I was just setting up, showing some example, but let me change it from 0 to 0 to 35. So limits of y-axis starts at 0, 35, and the breaks essentially tells where you what break size or what size of gap you want between your ticks on x-axis and y-axis. So breaks, the sequence tell you from 0 to 40 and jump by 2.5. So it starts with 0, 2.5, 5, 7.5, 10, 10 12.5, 15, 17.5, 20, and so on and so forth. I'm missing a bracket somewhere. That's the issue. Why is it showing me like that? Okay, and the scale and X continuous, again, weight, and limits is 0 to 7.5. So there's too much of space here. I want to reduce it. I don't want to show from 10 to 20. I possibly as well make it as 10. Let me make it as 10. And so the X-axis I want from 0 to 10, because 15 and 20 is, there is no data set in there. There is data point in there, so there is no point having that. And the breaks I want exactly the same. I can change I can have a different breaks across them if I want to, but right now I'm having the same. So just I'm trying to figure it out what mistake I made that this red square has come over here. Oh,
the
right.
end of the limits, there's 2.
Yeah, okay, over here. Right, okay, so now if we execute this particular one, and that's what essentially happens is like 0, 2.55, 7.5, 10. That's how customized. And on the y-axis and on x-axis also we have 0, 0.0, 2.55, and 7.5. So this is the way you can actually pretty much play with it. The next one is again achieving the same thing, but using a little bit different kind of code. So there is no, so as when you start using a ggplot to do a lot of plots, you realize that there are multiple ways to achieve exactly the same thing. And there's no way to say that one is better over the other. Some things will give you more control over the, provide you more control to get certain things incorporated, and some of them possibly won't. So as taking that into account, I think there are many more packages that are being developed like ggrid, ggRepl, and then there are many more out there which you can use. And they, at the back end, they use ggplot too, but they allow a lot more flexibility in terms of actually generating a particular graph. This is essentially the same. I think we're doing a scatter plots here. Here, G is equal to, so again, I'm using the scatter plot, and then I'm splitting based on the cylinder types. And that's how they are displayed. So now if you can look at the way, if you look at it, this has a gray background, has certain lines inside it. These lines are like white lines. And so this is called a theme of the plot. So this is a default theme in how the graphs are generally displayed. So theme is an aspect where you can change the look of the graph by manipulating certain criteria. So let's say if you want to just change in this one, if you use a particular theme, you can say background of the background of your plot should be gray. So then you can use theme within the bracket. This is a variable to change the background, and you can say that fill is equal to dark gray. There are other variables you can set it up with respect to having a boundary on outside. That's the basically rectangle fill, element rectangle fill, dark gray, and then basically the line is black and the size of thickness of the line is 3, and all those things you possibly can have in there. So there are themes that comes along with R, and at the same time there are themes which you can make of your own. So for example, this is a theme which I put together. I'm not going to go through all those particular variables. There is a link down which is talking about themes. So I would say recommend to read that one to get some feel about what are the different parameters you can set it up. So for example, this is a theme this is a theme I have put together, and now the same graph which I am looking up, let's say the P and cylinder. And now to this particular plot, what I'm going to do, I'm going to add the empty cars theme, which I have built over here. And what it does, it is just simply customize the display of the whole image. So you can see now basically the x-axis and y-axis points are labeled in blue. These are cyan color or light, what color you will call it is, this is light blue. And the pink are the, you can see the grid lines are there, and the background is light yellow. All those things can be set up in a theme. Now, when would you need a theme is so most of the times, if you look online, if your certain publications made in, let's say, in certain journals require certain kind of layout, background, and other things. So people might have already built themes around them one. So it's just simply have to download that particular theme. And if you're trying to publish in the same journal, just have your graphs ready with respect to everything, that this is your final graph, and just generally add the theme to it. And it will just basically change the display of it, which is acceptable by the journal in terms of publication. So these are the different default or inbuilt themes that comes with R. ggplot2 is, this is the classic one. This is line draw, so you can see these are lines basically pretty much same. The little bit colors changes here and there, but that's what it is, that each theme is different with respect to just getting the information displayed. This is black and white. So this is possibly pretty much what we are using so far, I think. And then we have dark. Then we have light. And then we have gray. So these are basically different themes that are out there. There are many more. So, and there's a link down somewhere. Okay, this possibly is the link where you can go and look at a little bit more in details. If it is, I think that's the link, but I will check it again. But essentially, you can build a theme by specifying different elements of a theme and make it suitable for the way you would like to have your graphs to be displayed. And if I'm not correct, there are about 40 odd variables you can set up to generate one given theme. So there's pretty much like everything is customizable over there. Any questions still here? Okay, so the next thing I just want to sure, go ahead.
Yeah, it might be like a very naive and weird question, but like, so sometimes we get the data and we want to add the statistic to that. So like p value and then
I'm coming to that. I'm coming.
Okay.
I'm coming to that one. And there's a data point at the end, and I'll come to that particular one. Okay.
Okay, thank you. We'll see there.
No worries. So here, what I'm just showing a violin plot. So what we saw earlier, a violin plot example was really, in a way, if I put lightly, is like really rudimentary, but you can customize it really beautifully and can have like a lot more information to be conveyed. And let's see one example of that particular one. So here what we are looking into a data called tooth growth. And in this particular data set, if you look at, there are three different columns. The first column is in terms of, I think, the length of the tooth, and then what the supplement. So there are two supplements. One is vitamin C, and I think VC, and then one more variable. So the two types of supplements that has been provided to the, I think, mouse. And these supplements had been again provided into doses of 3 levels, so 0.5 mg and 10 mg and 20 mg. So that's the kind of data I'm just trying. And let's say we want to do a sort of like a violin plot out of that. So let's go with that one. So the first thing what we're going to do is our dose is let me show you the table. Tooth growth $dose. So if you look at, there are 3 discrete variables. The 20 observations are with 0.5 dosage, another 20 with 1, and another 20 with 2, a mix of dosage. So essentially the 0.5 is not a numeric, but it's sort of like a category. So for the first thing is to convert this dosage into a category table. So that's what we're doing in this one over here. And then we were trying to, again, using the data set tooth growth, specifying that aesthetics is going to be the dosage, 0.5, 0.5, 1, and 2. And the y-axis is going to be, is the length. And then we're going to do a geom plot, geom violin plot. And if you look at, this is the geom violin. This is the default plot. So you look at the plot is actually pretty much trimmed on the ends, and this is generally to actually take care of some of the outliers. So I think about 10% is the default value, which is cuts off the data from top and bottom. So that's why you see this sliced one. But if you say trim equals to false, it actually it no longer trims it, and you see the really beautiful violin plots over there. We can also do a little bit more in terms of having like dots, or basically the distribution of the data added to the plots. So here, dot size is 0.1. So let me make it a little small. So yeah, that's where actually the violin plots are. In my term, I prefer, if between box plots and violin plot, I will tend to be more preferring to the violin plot, because in a way you can look at the distribution of basically you can say the shape of your violin plots to some extent gives you an information regarding how the data is distributed at each particular point. Which is in case of box plot, unless you do jitter plots, there is no way to know how the data is distributed. So here I have just marked the in a single line, but you can use a geom jitter or position jitter, and that will what it'll do is just distribute the data in. Oh, sorry, which one did I exit? Oh, okay, wrong line. Sorry about that. This is it. Yeah. So again, similar to like box plot, where we are having the each data point being present into in the box. Similarly, you can show the each data points within the violin plots as well. Then we can add, then you can use stat summary. So here we are going to add certain statistics, and here we are use a function called which is mean underscore SD, which calculates the mean and the standard deviation in length. And what is going to represent is going to represent a mean and basically a mean as a point, and then the range of standard deviation, I think, to certain values over there. Or that one. That's how it shows. So it's going to show the mean and then possibly the distribution of your data over there. Now, let me plot this one first. This is a more refined version of, you can say, a violin plot, also showing the box plot within it. So what we're doing here is ggplot. Again, the first is a data layer, then the aesthetics layers, and then we are specifying we're going to do a geom violin plot, but we don't want any kind of trimming. We also want a box plot, and the width of the box plot we have specified, and we'll say fill it by white. So all the box plots are actually essentially filled with white. And then, okay, sorry, I forgot about this one. So the fill equals to dose. So it's going to fill each of the basically violin plots by the dosage, so 0.5, 1, and 2. That's why the 3 different colors are added over there. Then we are simply changing the label, the plot of length by dose, and x is equal to dose per mix in mix, and the length on the y-axis. And finally, the same way what we added the statistic summary, like having standard mean and standard deviation. Here we are just only representing the, I think the should be the mean. Yeah, so that's what it is actually shown over here. Now just the question. Okay, this is the link. If you want to, there is a lot more you can do with respect to the violin plots, and it's unlikely that I can cover everything. And if you, this is the link if you want to go over and follow more in detail. Actually, the same code and some little bit extra. You can visit that particular link and you can get some information on those violin plots. Okay. Now, in order to add some statistical tests or basically have them incorporated in our plots, there's a library called ggpubr, which you can use, and it has multiple like tests built inside it: t-test, Wilcoxon test, and then ANOVA, Kruskal-Wallis test. And all those tests are part of that particular package. So let me show you one simple example. So here, first what we're doing is we are doing a pairwise comparison. And we are going to compare the means as the length, compare the means, which is of the means of the length as a function of dosage, and data we are going to use this tooth growth. And during making this particular, in these comparisons, what comparisons we can specify is we're going to compare 0.5 doses with one doses with 2, and 0.5 with 2. So all of them we are comparing with respect to each other. And now we're doing ggplot, tooth growth, x equal to dose, y equals to length, color equals to dosage, and palette is essentially what kind of color we are using. So this is a particular color scheme. So if you want to specify different one, you can specify different one, and that's okay. And then we're saying state compare means, and comparison is equals to my comparisons. The comparisons we are drawing are these comparisons which we have listed over here. And to that one, what we are basically adding is all the stats what we have generated previously. So this is somehow this is how the finally the graph would be basically plotted over here. So this is actually the doses for 0.5, 1, and 2. And then their p-values are basically specified on top of each of those ones. Similarly, in case of, let's say, this is another example where I'm actually right now in this example creating a data frame called DF. And if you look at DF, sort of, there's a group A, B, C, and D, and then there are certain bar graph, let's say, are associated with them, and we know there's certain values for each of those bar graphs, and we want to put all that information in this particular graph. So let's go about, so I'll just plot it first and then basically go over that and then show it. Okay. And in this case, we did the first part is actually plotting the bar graphs, what we are doing over here. Then, and the next part is what we're doing is geom path. And the geom path is essentially describing this each of the bar, how it has to be plotted. So for example, if you look at this particular bar, which is the first one, it starts at, so this is A, B, C, and D. You can think as 1, 2, 3, and 4. And so the data point we are starting, the line is starting at 1,25, and going above 1, you can say one scale, and which is 1,26. Then it goes horizontally. So it goes from 1,26 to 2,26, and then comes back at from 2,25. And that's what essentially we are doing. So this is 1,25. That's our starting point was. And from there, we went to 1,26. That's basically moved like one increment above. Then we went from 1,26 to 2,26, which is like going all the way across over here. And then basically putting another one, 2,25 over here. So these three are basically, these three data points, what you see, are nothing but essentially describing how these lines has to be plotted in this graph. And then we are doing annotation of each one of those ones. And these are the p-values we have previously determined. Let's say whatever we essay we have done or whatever the test we have done. And we're simply saying that plot, annotate using this particular text, which is these text. And then going to use specify the location where this text has to appear. So we say at 1.5, which is in between 1 and 2, which is some middle. And then basically at 27, y with respect to y-axis at 27. So you can move up or down. So if you change it to some other thing, like say 29, that particular label is going to go a little bit above. So now it has moved up. So you can like go up and down based on that one. And that's the kind of different annotations you can do with respect to this particular, when you're actually doing the graphs in terms of ggplot2. This is pretty much the end of ggplot2. I don't have anything more to cover. If you have any questions, I'm more than happy to answer. But again, as I said, most of these things are really, really basic. But it still can let you do a lot of graphs, lot of different kind of graphs. And the idea behind here is to just to give you an introduction to ggplot2, how you can get started with it. There's a lot more complex graphs you can generate, and there are a lot more different libraries are out there which you can use. And that can help you actually further refine your plots in much more beautiful way. So I don't have anything more to add. If you have any questions, I'm more than happy to take those. Otherwise, we are done with respect to the sessions which we have started with.